Hi everyone, my name is Carly Lossie and this is my Physics 2212 Lab 2 Lines of Charge presentation. I hope you enjoy. In the previous lab, we found the excess electrical charge of Scotch or clear tape by using single point charges for the tape. In this lab, we will build on this knowledge by finding a more accurate charge for the tape by using distributed line charges instead of single point charges. We will be using the concepts of Coulomb's law and superposition throughout the lab. And again, our goal is to use these concepts to find a more accurate electrical charge for the tape. Moving on to our models, on the top right we can see the model we used for Lab 1. To review, we said that the pieces of tape are both negatively charged and therefore repel each other. The model for Lab 2 is on the bottom right. Because we are using distributed charges for the tape, there are a lot more charges present. Overall, the models are similar in concept, though the model for this lab will give us much more accurate results. Now we will be moving on to our assumptions of this lab. First off, we will be ignoring any air resistance that the pieces of tape may feel. Also, we will be assuming that the tapes hold the same total charge and that the charges are evenly distributed throughout the pieces of tape. Now, before we begin discussing the glow script code and outputs, we will need to go over the data we collected. The data we used, for the most part, is the same data from Lab 1. To recap the most important components, the length of both pieces of tape is 0.231 meters, the mass of the pieces of tape is 2.3 times 10 to the 4th newtons, and the vertical distance is 0.024 meters. Looking at my glow script code, I start by inputting the necessary variables that I will need to code the lab. Next, I find the observed values. Then, I use this data to find the electric field of the tape. Next, we use a function that creates the line of charge, and then create an object that represents the pieces of tape as seen in the second picture. Now we will move on to actually calculating the electric field and force. And then finally, we will find the net electric force and gravitational force and use this data to create the model that the code will output. Moving on to my glow script outputs, it can be seen below. The code outputs this model. The white arrow represents the net electric force on the top tape. The yellow arrow represents the gravitational force on the top tape as well. The green arrows represent each electrical force charge of the individual points on the top tape experienced due to the bottom tape. The red dots represent each point charge that is distributed on the top tape. The blue dots represent each point charge that is distributed on the bottom tape. If we wanted a more accurate and precise model, we could increase the number of point charges on each piece of tape. In this model, there should be 9 on each. The magnitude of the electric force found by my code is 2.66 times 10 to the negative 3rd newtons. The magnitude of the gravitational force is 2.26 times 10 to the negative 3rd newtons. Finally, we will conclude this lab by answering the reflection questions. The first question asks, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you get with your line charge model. The single point charge model gave us a charge of negative 1.2 times 10 to the negative 8th coulombs, while the line charge model gives us a charge of negative 6.5 times 10 to the negative 8th coulombs, which leaves us with an astonishingly high estimated charge increase from the single point model to the line charge model. Furthermore, why do these estimates differ? The point charge model only takes the 2 points into account, while the line charge model accounts for the points and the space between the points as well. Also, which value is more likely to be closer to the real value and why? I believe the line charge model is more likely to be closer because it takes into account more variables that allow the calculations to be more specific and less approximated. Basically, less assumptions mean more accurate. Thank you for watching my Lab 2 presentation. Have a great day.